Got a 2010 Nissan Maxima. This is the vehicle I put the engine in, and just trying to get all the kinks worked out. So right now, dealing with 18 p1804 code, and it's related to the VIAS, the variable induction air system, which consists of the intake runners. So I think that one up there is bank 2, and then that one up there with this diaphragm here is bank 1. And then we got the cylindroids for the corresponding cylinders. This is bank 1 or bank 2. But I'll know once I go into the diagnostic feature, the active test. I think that's bank 1. That's bank 2. So what's going on? The circuit's high. So when you get the P1804, I want to say, let me make certain. I think it's that code, P1804. I had a couple other codes, but I started disconnecting some things. Nope. So it's 1801. Yeah, 1801. So that's the code we're dealing with. So when you get that code, it detected low or either high voltage. So it's pretty general, but it's only two variations of what that code could create, which is a circuit fault. That's the thing that's mutually in common. So when you get P101, when you get that code, you're going to get it detected low or high voltage from what the code setting criteria state. Now, from what I understand, the actuating systems get operated once you start driving it from what the drive cycle states, like at cruising speed. But I do believe that I think it sends like a bias voltage or like some type of low voltage to the circuit during probably like an initial startup to check the valves or the solenoids. So I don't have anything. No power or anything going to it. The key is on, so I'm not commanding anything to happen at the moment. I just have my piercing pins connected and just checking the circuit. So I do currently have 10.81 volts, and the other one, I don't have a voltage value on this one. That's strange. I got voltage on one but not the other. I don't know if that's related because of the code. Let me clear the code and see if the voltage goes away. Hope it stays. All right, the code is cleared. Let's see if it's still there. And it is. Let's go to the other one. It's weird. The piercing pins are in there. This one has voltage, but this one doesn't. Let me disconnect it and see what happens. There's no voltage. Voltage down there bleeding into it. I don't know if that's the positive one or not. Okay, this is the battery voltage side, the red and white looking wire. So there's voltage going through here. So that's 13 volts. This one here has none. So this works off of a ground side switch. So when the PCM commands the solenoids to work, it sends a ground signal to the opposing wire. So the red and white are the common between the two, and the like a black and white and the purple are the control wires. So what I'm gonna do, I got my raggedy cheap piercing pins. I don't have my other ones in my immediate reach, so let's do these in there. So the wire may look a little ugly. So what I'm gonna do, I'm gonna go through my scan tool and we're gonna do a bidirectional control and see what happens. So with the key on, engine off, 12 volts on the red wire. Just out of curiosity, if I was to do I'd probably turn the key off. If I was to do like a resistance test, what would happen? Let me do one. Let's cut the power. Let me cut the car off. Let's do a resistance test. So 318 kilo ohms and 34 ohms. That's interesting. One has 34 ohms. One other one has 314 kilo ohms. Make sure these are in good. Let's try it again. And they're connected, so I probably should disconnect them and see if the value changes. And I'm gonna do that. So let's 323. Okay. There's no value. This was 34 ohms, connected, disconnected. It's dancing. So, lost my piercing pin. I need to get my other ones. These are just not that good quality. So both of them disconnected. I didn't have a value, but with them connected, I did have a resistance value. So with them disconnected, no value on both banks. This one connected had 312 k ohms. This one had 34 ohms. So this one is looking like the culprit. This one looks like it's going to function like it's supposed to, because these are solenoids, and solenoids need to be able to ground out. So I'm thinking like a oil control valve. The ohm is going to be like 16 ohms. You know, typical solenoids, because of how since they're like inductive, they have to be able to pull in current and change that coil, the state of the coil. So this one's look like it's being defective. So I could just change this one, but let me go through the bidirectional portion and try to control it. So naturally, with the key in the on position, so let me turn the key back on. So right now, keys in on position. I'm going to do a bidirectional test. Now, if you don't have a bidirectional tool, you can simply just apply battery voltage to the solenoid down at the bottom, negative and positive. Same for the other one, negative and positive. Let me add, the good thing about this system is it doesn't have a position sensor on the actuator, so these can be bad. The only thing it will just inhibit is the power function. So the actuators, the actuated diaphragms, because they may not operate, it's not going to cause a check engine light. It's just going to cause performance problems. The circuit, being that it needs to know the position of that based off the voltage value, is going to create a check engine light. So this is why we're checking these on this vehicle. All right, being that I got the key on, I want to do a bidirectional test. So I already went over, if you decide to test it with, if you don't have a bidirectional tool, use 12 volts, like the battery power. Just touch those two pins and listen for a click. Just because a click doesn't necessarily mean it worked. The solenoids can actually still bleed off. That can happen. Solenoids fail in so many different ways. So one of the two, they'll bleed off or just not operate. Stay stuck open, stay stuck closed, or leak. These seem like one of them's not operating, which is looking like this one with the blue dot on it. All right, the scan tool I'm using is the Autel. I use Autel products, the MK908. And I'm in the function menu here. We're going to go to active test. We're going to go to VIAS, variable induction air system. I'm going to go to SV1 here. And what I'm going to do, pull up all these PIDs. It gives me an on and off function, so I can just keep on cycling it. All I'm going to do, assuming that you're using a test meter, you can pierce both of them, because one side's going to dispense positive, one other side's going to create the negative. That's the control wire. Let me see if I can show you this. So you can see this, that is on. I don't know if you'll be able to see that. Yeah, I think that'll work. So we got ohms. All right. This is just a check circuit, so I am producing 13 volts. This is on. I'm waiting for the state of off. It is off. It is producing, what was this, 10 volts. Let me switch them. $13 is on. It's going to go off shortly. It's off. It's producing 10.7 volts. So being that I still have a voltage value because it has 12 volts, that resistance is going to the computer system. So it's just pretty much measuring the difference in value. So I'm going to connect these. Listen for an audible click. It's off. It's on now. I also have a test light. This is what I really recommend for a load test. I'm on the battery positive with the alligator clamp. So I'm gonna short the test light out on ground, and it's going positive. It's illuminating the light. So what I'm gonna look for, being that my alligator clamp is on battery positive, I'm gonna be looking for ground, because this is the ground side switch. I hear an audible click, so our light should illuminate when it activates. It's off now. It's on. I don't have any activity. Oh, I'm on the wrong wire, that's why. Okay, there we go. I'm on the purple wire for bank 1. So this is bank 1. It's off. It's going to cycle back on. And there we go. So I hear an audible click. So this has operation. We're going to go to bank 2. Since you got the gist of it, I'm going to pull the computer off the screen here. Just narrate what I got going on. Go back to out of test. Go to bank 2. variable inductive air system on bank 2. All right, the connector is disconnected. I'm gonna connect it. The red white wire is what produced the battery voltage before, so we're gonna go to the what look like white and black wire and look for on-off signal and listen for audible click. Our on signal. Nothing. That's my test light here. Test light must not be. It's lit. I ain't get anything. Test light's not even lighting up on this one. Yeah. Let me test for 12 volts. I got 12 volts on one side. I just don't have any command. Make sure my clamp is in the appropriate spot. Might not be pierced well. Check your connections. Oh. All right, so my connection was bad. It's on. No audible click. It's off. No audible click. So that solenoid is bad. Luckily, the used engine came with more solenoids, and these look interchangeable. So I do have a used one from the old motor. Well, the new motor. These are the old one that was on the motor, so this had to have been a pre-existing problem for this car. So let me grab the new one, get it off the rail, the vacuum rail, and then we'll install it and see if we hear audible click. All right, I got the new one. This looks beautiful. Looks brand new. Uh-oh, why isn't my? Oh man, my battery's low, that's why it's not working. So I got a new solenoid. Came with the harness. Simply what we're gonna do, disconnect it and install it with new vacuum lines. I really don't have to change the vacuum lines. I'm just rather do it because they're older. I'm glad I only bought 4 of these things because these are just cheap. I don't know why. The screw-in is so much better. So we got that off. I'm gonna take the new used one, install it without trying it, and hope it worked. The vacuum lines on it. I don't need this one anyway, the red one, because we know we have a good circuit. We just need to test the black and white one. Prove that it's sending power and we can listen to the audible click. Oh, you hear that? It's working. Work. Come on, there you go. It's clicking. Cool. There we go. Just that easy. All right. I'm not gonna break my neck over it. The circuit works now. And you know what? Let's test the test the voltage now. Because this should have the same ohms as the working one now, which was about 34 ohms. Yep, 34 ohms. That's what that's making. Let me see what it is disconnected, just in case you're in the field and you need to test it. 33 ohms, so they're the same. 33 and 34 ohms if you disconnect it right at the solenoid. Awesome. That was quick and easy. Quick and easy. Luckily, I had a used one because it came with the used motor. So, all right, that was fast. About 20 minutes and in and out. If anything happened, I'll definitely let you know. This car does have another code related to the transmission, but this transmission was replaced. I'm not sure why I have a lockup solenoid code. So I'm going to do some basic looks into that. And if becomes anything interesting, I'll definitely start recording. But my battery is low right now. So, but if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed, how to reach us more work. See you on the next one.